Hello and welcome to a lesson on equivalent trig ratios. So this is lesson number 3 in Unit 4. We are going to start by reviewing what the sine graph looks like and what the cosine graph looks like. And so what we're going to do is we're going to plot these graphs, but now we're going to use radians. Okay, so recall that 90 degrees is pi over 2 radians. 180 is pi radians. 270 is 3 pi radians, and then 360 is 2 pi radians. And then on the other side we have negative pi over 2 and negative pi. So I'm not gonna extend all the way to um, the third and fourth quadrant. And then we've got 1 and negative 1. So max and minimum value of sine and cosine. So sine starts at 0, 0. So it has a point at 0, 0. It also has a point at pi over 2 and 1, so 90 and 1. It has a point at pi and 0, a point at 3 pi over 2 and negative 1, and then a point at 2 pi. Okay, and so that's what one cycle of sine theta looks like, plotted in radians. Now we can extend this a little bit as well, if we want to. So let me do that. Oops. So negative 1. So there's also a point at negative pi over 2 and negative 1. And then a point at negative pi and 0. And then the graph continues on. And same thing here. All right, so now let's do the same thing, but now for cosine. So what I'm going to do is I'm just going to plot it on the same grid, actually. Just going to use a different color. So this is, y is equal to sine of theta. So now cosine of theta. So there's a point at 0 and 1, a point at pi over 2 and 0, a point at pi and negative 1, a point at 3 pi over 2 and 0, and a point at 2 pi and positive 1. And then looking at the negative values, so there's also a point at negative pi over 2 and 0, and negative pi and negative 1. So in terms of its shape, its general shape, this is what cosine theta looks like. And it keeps on going. So it has an unrestricted domain, so it goes on forever. All right, so having looked at these two graphs, these two trigonometric functions, we're now going to look at number 1 here. So given the following graph, write a possible equation for the function. So take a moment to think about what a possible equation would be in this case. So just by looking at this, what I can see right away is that this kind of looks like sine, but it looks like it's sine that's being reflected along x-axis in this case. And so what I could write for this is I could say that the equation of this function could be f of x, or f of theta actually, because it does say theta there. So f of theta is equal to negative sine of theta. Could be an equation of this function. Now, in terms of let's say sine, because we can also in terms of cosine, because we could also write a cosine equation for this. Normally cosine starts at 0 and 1, but here it looks like it's being translated pi over 2 units, pi over 2 radians to the left. And so another possible equation that can be written is cosine, and so there's a phase shift here. So theta, it's shifted to the left, so it's going to be plus pi over 2. Okay, so cosine of theta plus pi over 2 is another possible equation here. So using your knowledge of transformations, check that the 4 following equations satisfy the graph. Now we know that the first one satisfies the graph, right? F of theta equals negative sine theta. We also know that the fourth one satisfies the graph as well. Now looking at part B, would sine of theta plus pi, would that be the same or as the other equations? Would it also be, could it be used to model this graph here? Does it match the graph? So what does this actually mean? Theta plus pi. So that means we're translating pi units to the left. Okay, so translating pi units to the left, and we can see that that would still work, right? So if we translate pi units to the left, right, we have a cosine, we have a sine function that's just been translated, right? Pi units to the left. So that means that it starts at negative pi. So that works. But then we just have to check C as well. So f of theta is equal to sine theta minus pi. So this means that it's being translated pi units to the right now. And we can see that that's going to work as well, actually, here. Right? Sine starts along the x-axis, right? Or axis of the equation. Or equation of the axis, which is if you recall from grade 11, it's the middle horizontal line, the line in between the maximum and minimum, the C value. So this would work as well. If we take sine in this case and we shift it pi units to the right, we would get this this graph. Okay, so looking at number 3 now, it says explain why f of theta is equal to sine of theta plus 2 pi is the same as f of theta is equal to sine of theta. Now, you have to recall what the period is of sine and cosine. And we can see from the graphs that we've plotted that the period, so the length of one cycle for sine and for cosine is 2 pi, or thinking back to grade 11, 360 degrees. So if we translate the function, so plus 2 pi means what? We're translating 2 pi units to the left. So there's a phase shift of 2 pi to the left. If we translate 2 pi to the left, or we translate 2 pi to the right, it doesn't actually matter, we will get the exact same function. Okay. And And so the reason for this is because the period is the same, right? The period is being added or subtracted, so it's not going to have any effect on how the graph looks like. So the period of y is equal to sine theta is 2 pi radians. So translating by 2 pi will not change the appearance of the graph. Since sine is a periodic function, since sine is a periodic, so it repeats, it's repetitive function. All right, so we want to write a similar statement for cosine theta. So what we can write is that cosine of theta is going to equal cosine of theta plus or minus 2 pi. Okay, so we could either add 2 pi or subtract 2 pi. Since the period of cosine is 2 pi radians, that's not going to have any effect on how the graph looks. Okay, so cosine theta is equivalent to cosine theta plus 2 pi or minus 2 pi. Now we want to write a similar statement now for tangent theta. How is this statement different than sine theta or cosine theta? So you have to think back and try to remember, what is the period of tangent? Yeah, so tangent has a period of 180 degrees. It's half the period of sine and cosine. So if we change that to, if we convert that to radians, that would be pi radians. So the period of tangent is pi radians. Okay, so period would be pi radians. So then the equation would look like, the statement could look like, so tangent theta equals tangent theta plus or minus pi. Okay, so we add the period or we take the period away, that's not going to change how the graph looks. So yeah, so tangent theta is equivalent to tangent theta plus pi or tangent theta minus pi. Okay, so now let's talk about odd and even functions again. Now we know that f of theta is equal to cosine theta is even because it is symmetrical with respect to the origin. Respect to the And so if you look at its graph, so I would look at its graph. Actually, sorry, not with respect to the origin, with respect to the y-axis. It has line symmetry, right? So it's even because it's symmetrical with respect to the y-axis. It's a mirror image, right? So if you look at the function, you can see that it is a mirror image here, right? The cosine function is the blue one. So it's an even function. It's symmetrical with respect to the y-axis. While sine, on the other hand, is an odd function because it's symmetrical with respect to the origin. Okay, so it has point symmetry, right? We can have a look at it again, so we can see here that yes, there is rotational symmetry with respect to the origin. If you rotate it 180 degrees clockwise or counterclockwise, you get the exact same graph, the exact same function. So therefore, cosine of negative theta is going to equal cosine theta, right? It's just going to take the negative away, basically, eat it up, while sine of negative theta is going to equal negative sine of theta, right? There's going to be a negative in front of it. So just recall what we've talked about previously in the past about what the algebraic test for determining if a function is even or odd. So is tangent theta even or odd? How do we figure this out? So there's something we can do. So as long as you remember that tangent theta equals sine theta over cosine theta, okay, then what we can do, I'll just write this as f at theta in this case. So if we write f at negative theta, right, we're going to get, so sine of negative theta over cosine of negative theta. And from this, we already know that sine of negative theta, because sine is an odd function, is going to return negative sine theta. And substituting negative theta into cosine theta is going to give back positive cosine theta. And that's because cosine is an even function. And so we basically get a negative of the original function, right? We get negative f of theta. So therefore, we can kind of conclude, we can just write it here. So tangent theta is odd. Or we could say, yeah, is an odd function. Okay. So what statement can we write? So we can write that tangent of negative theta is equal to negative tangent of theta, because tangent theta is an odd function. It has odd symmetry or point symmetry. Okay, so take some time to try to fill out this table. So you can pause the video now. Try to fill this out, and then after you have done so, you can unpause the video. Okay, so assuming that you have filled this out already, so sine of pi over 3. So recall that pi over 3 is 60 degrees. So sine of 60 degrees, remember this is a special angle. Recall that this is root 3 over 2. Cosine of 60, or cosine of pi over 3, that's going to be 1 over 2. Again, this is coming from one of the special triangles. Tangent of 60, or tangent of pi over 3. So what we want to do is, in case you don't remember, so let's say it is easy to not remember all of these. Draw the special triangle, so root 3, 2, and 1. Pi over 6, pi over 3. And so now tangent of pi over 3, so opposite over adjacent, so that's just going to be root 3. Root 3 over 1, right? Okay, so cosecant now. So cosecant is the reciprocal of sine. So it would just be 2 over root 3. You can rationalize it to get 2 root 3 over 3. Secant is the reciprocal of cosine. So reciprocal of 1/2 is just 2. Cotangent is the reciprocal of tangent. So that would be 1 over root 3, which if you rationalize is root 3 over 3. Okay, now looking at sine pi over 6, so from the special triangle, that's 1 over 2. Cosine of pi over 6 is root 3 over 2. Tangent of pi over 6 is 1 over root 3, which is the same thing as root 3 over 3. If we rationalize, cosecant is the reciprocal of sine, so cosecant of pi over 6 is 2. Secant is the reciprocal of cosine, so this would be 2 over root 3, which is 2 root 3 over 3. And then lastly, cotangent, so that's the reciprocal of tangent, so that would just be root 3. Okay, so taking a look at this table, do you notice any patterns? Are there any formulas that we can write? So there are. You might notice that, for example, some of the values are the same. So sine pi over 3, this value here, so it's root 3 over 2, is the same thing as cosine of pi over 6, right? Or cosine of pi over 3 is 1/2, while sine of pi over 6 is 1/2. for tangent of pi over 3 is root 3, and cotangent of pi over 6 is root 3. Okay, and then there's this, we can see there's similar relationships here as well for other ones as well. So for example, secant pi over 3. Secant pi over 3, so 2 root 3 over 3. Where else is there 2 root 3 over 3? Here. Right? Cosecant and secant. Okay, and then 2 here, so secant pi over 3, and then there's another 2 over here. So based on this, we can actually write some formulas. Okay, we could write something like sine, okay, of pi over 3 is equal to cosine of pi over 6. And cosine of pi over 3 is equal to sine of pi over 6. And we've got tangent of pi over 3. What is that equal to? That's equal to cotangent of pi over 6. And we got some other ones, right? Cosecant of pi over 3 is equal to secant of pi over 6. Secant of pi over 3 is equal to cosecant of pi over 6. Now notice that these angles are complementary, which means they add up to 90 degrees, or pi over 2 radians. Okay, so there's definitely something going on here. There's some kind of pattern here. And it has to do with complementary angles. Okay, and so there's some other ones here that you can write as well, but that I didn't include. So in a right triangle, so a right triangle has two acute angles. If one angle is theta, the other must be pi over 2 minus theta. So if I have an angle theta here, and then this is obviously 90 degrees, right? So that would be pi over 2. This other angle over here, this top angle, would have to be pi over 2 minus theta. It has to be complementary to theta, this angle. Because theta and pi over 2 minus theta have to add up to 90, right? If there's a 90-degree angle in the triangle. Okay, so if that is the case, what we can actually kind of get from this, and also what we saw up top here from this investigation, is we can write what are known as the co-function identities for angles that are less than pi over 2. So sine of theta can be written in terms of cosine as cosine pi over 2 minus theta. Okay, so that's kind of interesting. And we kind of saw that up top, right? We saw sine of pi over 3 is equal to cosine of pi over 6. So to get pi over 6, what do? We do pi over 2 minus pi over 3. Now, for cosine of theta, that would be sine of pi over 2 minus beta. So kind of the same, very similar to the other one. Now tangent, as we saw before, for tangent we saw that it was equal to cotangent of pi over 2 minus beta. So cotangent pi over 2 minus beta. Okay, and cosecant was secant, right? Secant pi over 2 minus beta, complementary angle. Secant was cosecant, was equal to cosecant pi over 2 minus beta. And then cotangent was tangent pi over 2 minus beta. Okay, so these are known as the cofunction identities. They have to do with a 90-degree angle, right? They have to do with two complementary angles that add up to 90. Okay, so let's use these. Let's use the cofunction identities in order to evaluate these here. So starting with sine of 3 pi over 10. So we know that that's going to be cosine of pi over 2 minus 3 pi over 10. And so what is that going to become? That's going to be cosine. So 5 pi over 10 minus 3 pi over 10. It's going to be cosine of 2 pi. 2 pi over 10, which is equivalent to cosine of pi over 5. Okay, so if you set your calculator to radians and you key in sine of 3 pi over 10 and press equals, and then you also do cosine of 5 pi over 10, you're going to get the exact same value because they're equivalent to each other. Okay, so now for the next one. So this is going to be, in terms of sine of pi over 2 minus 3 pi over 8. So sine of 4 pi over 8 minus 3 pi over 8, which is going to give us sine of pi over 8. Okay, now for cotangent 2 pi over 5. So we know that's going to be, it's going to be tangent of pi over 2 minus 2 pi over 5. So that's going to be tangent of, so 5 pi over 10 minus 4 pi over 10, which is going to be tangent of pi over 10. Okay. Now for secant, so we know that's going to be cosecant of pi over 2 minus 3 pi over 10, or over 14, sorry. So then this would become cosecant 7 pi over 14 minus 3 pi over 14, which is going to give us cosecant of 4 pi over 14, which is cosecant of 2 pi over 7. Okay, now we've got some more here. So now these ones are, we actually can't really use the same cofunction identities from before because these angles are actually not in quadrant 1. So the cofunction identities that we've been using so far, these ones here, are only applicable to angles that are less than pi over 2, so less than 90 degrees. Well, what happens if they are more than 90 degrees? So what you have to realize is that we can write this in terms of still sine, but in terms of the first quadrant. So sine of 11 pi over 6, right, is sine of 330. The related acute is 30, or pi over 6 radians. We can write this as negative. So we know sine in the fourth quadrant is negative, right? And we know sine in the first quadrant is positive. So if we take sine in the first quadrant, just put a negative in front of it, it's the same thing as sine in the fourth quadrant. So sine of 11 pi over 6 is the same thing as negative sine of the related acute angle, which is pi over 6. Since 11 pi over 6 is 330, the related acute angle is 360 minus 330, which is 30. 30 is pi over 6. So this is equivalent to sine of pi over 6. However, we have to put a negative in front because it has to be a negative ratio, since 11 pi over 6 is in the fourth quadrant. So what we can do with this now is now we can use our cofunction identity because now our angle is in the first quadrant, right? Pi over 6. It's less than 90 or less than pi over 2. So we can write this now as negative and then cosine of pi over 2 minus pi over 6. And so that's going to be negative cosine of pi over 3, right? Because pi over 3 is complementary to pi over 6, right? Pi over 3 we call is 60 degrees. Okay, so now for sine of 5 pi over 6. All right, so for this one, so this angle is slightly less. This angle is slightly less than pi. Okay, so since it's slightly less than pi, that means that it is in the second quadrant. Now recall that sine is positive in the second quadrant. So we're expecting sine of 5 pi over 6 to be positive. Now the related acute angle here is going to be pi over 6 because this angle here is 150. Okay, so related acute angle is 180 minus 150, which is 30. And so if it's 30 in radians, that's pi over 6, right? So this is just equivalent to just sine of pi over 6. That's what the ratio is going to be, which is 1/2. That's what it's equivalent to. But what we're going to do now is we're going to write this using the cofunction identity, right? So we're going to write it as cosine of pi over 2 minus pi over 6. And so that's going to be cosine of pi over 3. Okay, so that's what that's equivalent to. using the cofunction identity. Okay, now sine of 4 pi over 3. Okay, so 4 pi over 3, that is in quadrant 3 because it's a bit bigger than pi. Pi is 3 pi over 3. So 4 pi over 3, you got to add pi over 3 to 3 pi over 3, or to pi. So that would be, we're adding 60 to 180. So it's 240 is the angle in degrees. So we're in quadrant 3. We know sine is negative in quadrant 3, according to the cast rule. So because it's negative, it's going to be negative sine. Now our related acute angle we know is pi over 3, right? Because our principal angle is 4 pi over 3. So this can be written as negative sine of pi over 3. And now using the cofunction identity, that's going to be negative cosine of pi over 2 minus pi over 3. And so that's going to be negative cosine of pi over 6, right? The complementary angle. Okay, and it kind of makes sense that it's negative, right? Because both sine and cosine are negative in the third quadrant. So we would expect the cosine ratio to also be negative. Okay, now looking at cosine of 5 pi over 6. So first we have to figure out, okay, which quadrant is this in? So 5 pi over 6 is slightly less than pi, because pi would be 6 pi over 6. So 5 pi over 6, if you take basically pi over 6 away from pi, you get 5 pi over 6. Now, we know that in the second quadrant, cosine is negative, according to the cast rule. And our related acute angle is pi over 6. So we can write this as negative cosine of pi over 6. That's what it's equivalent to, if we write it in terms of its related acute angle. And now using the cofunction identity, this is going to be negative sine of pi over 2 minus pi over 6, which is going to be negative sine of pi over 3, right? The complementary angle. Okay. Now looking at example 2, so given that sine pi over 5 is equal to 0.5878, use equivalent trig expressions to evaluate cosine of 3 pi over 10. So first you need to realize that 3 pi over 10 is in quadrant 1, right? Because it's less than 5 pi over 10, which is equivalent to pi over 2. So it is in quadrant 1. So we can just use our regular cofunction identities from that table. So we can write this as, so cosine of 3 pi over 10 is equivalent to sine pi over 2 minus 3 pi over 10. So I'm using the cofunction identity. And so that's going to be sine of 5 pi over 10 minus 3 pi over 10. So just getting a common denominator so I can subtract the angles. And so this is going to be sine of 2 pi over 10, which reduces to sine of pi over 5. Now sine of pi over 5, according to what it says here, is 0.5878. Okay, so that means that this would have to equal 0.5878. Okay. So cosine of 3 pi over 10 is equal to sine of pi over 5, which is as a decimal value. That ratio is 0.5878. Okay. Now, we got example 3 here as well. So, yeah, this video has been kind of long so far. So I'm going to actually split this into two parts, this lesson. Okay, and so I'm going to end it here and then make sure you also watch part 2 for the continuation of this lesson.